Good day everyone. Today I will be teaching you how to graph polynomial functions. Before that, let's have this one first. This will help you graph polynomial functions easily. Okay, supposedly we have here column 1, which is the polynomial function. Next is the degree and the sign, the degree or whether it is odd or even. Next is the sign of the leading coefficient. Next is the number of turns. We have here end behavior and the sample graph. Okay, here we have number 1, f of x equals negative 3x cubed minus 5x plus 6. So if you're going to graph this one, when you were in grade 7, grade 7 and grade 8, you were able to learn linear function, how to graph linear function, where it is just only a straight line, whether it rises to the right, falls to the left, or rises to the left, or falls to the right. When you were in grade 9, you were able to learn parabola, or quadratic function, whether it is concave up or concave down. Here in grade 10, we're going to discuss all of those. Linear equation, or linear function, quadratic function, cubic function, quartic function, and so on and so forth. So we have here in number 1, we have a cubic polynomial. And how do we graph that one? Before that, let's have this one. So what is the degree here? The degree is 3. It is the highest exponent. So the degree here is 3. And 3 is an odd number. Next, the sign of leading coefficient. What is the sign of the leading coefficient? This is the leading term. So this is negative 3 is the leading coefficient. What is the sign? It's negative. Okay? Number of turns. So when you're in grade 9, the number of turns of a quadratic function is just 1, whether it is concave up or concave down. So it is just concave up or concave down. Right? Since we have already cubic, how many turns does the cubic have? So it is just simply n minus 1. N is the degree, and minus 1, that is 2. So the number of turns here is 2. Like when you were in grade 9, the highest exponent is 2. 2 minus 1, that is 1. So the number of turns. So let's have this sample graph first. Now, in a graph there is right tail and left tail. So if this is the right tail, this is the left tail of the graph. Right? So in here, in going to determine if the right tail is going up or down, let's look at the sign of the leading coefficient. The sign of the leading coefficient is negative. We will draw first the right tail of the graph. The right tail. If this is the graph, this is the right tail. This is the right tail, this is the left tail. Okay? So, if the leading coefficient is negative, the right tail is going down. So this is going down. Again, if this is negative, this is going down. So how many turns? We have 2. So 1, 2. So the sample graph or the graph looks like this one. It falls right. It falls right means the right tail goes down or it falls. The left tail going up or it rises left. So this is now the sample graph. So what is now the behavior of the graph? The end behavior of the graph, as x goes to positive infinity. As x goes to positive infinity means as x goes to the right, because the numbers are positive going to the right, right? As x goes to the right, which is positive infinity, y goes to this one, y. look at the right tail. It goes down. So, what are the numbers going down? Those are negative numbers. Right? So that as x goes to positive infinity or goes to the right, y goes down or going to negative infinity. Next, as x goes to the left, what are the numbers to the left? Those are negative infinity. As x goes to the left, look at the left tail. Go left tail. It goes up. So what are the numbers going up? So that is positive infinity. In a y and x axis, this is y, this is x. The numbers here is going to the right. These are positive infinity. Going to the left, it's negative infinity. Going up, it's positive infinity. Going down, the numbers here, going down, which is negative infinity. Okay, here, as x goes to the right, here goes to the right, goes to the positive infinity. Where is the right tail? It's here. It's going down. So that is negative infinity. So y is negative infinity. Next, as x goes to the left, what are the numbers to the left? Negative infinity. Where the right tail goes? The right tail goes up. The right tail goes up. What are the numbers going up? Those are the positive y numbers. So positive infinity. So the y is positive infinity. Okay, so let's have number 2 example. The degree here is 2. 2 is even. Now, what is the sign of the leading coefficient? The sign of the leading coefficient is here. The leading term is x squared. The sign is positive. So, positive. How many turns? So, n minus 1, 2, 2 minus 1, that is 1 turn. Okay, what is now the sample graph? Now, let's draw again the right tail first. The right tail. And if it is going up, the sign of the leading coefficient must be positive. It is going down if the sign of the leading coefficient is negative. Since this is positive, so the right tail goes up. And how many number of turns? So we have 1. So turn is this one, 1 turn. So this is the graph. This is what the graph looks like. So what is now the end behavior? As x goes to the right, which is positive infinity, goes to the right. Look at the right tail. It goes up. So y goes up. What are the numbers going up? Positive infinity. Next. As x goes to the left, negative infinity, the left tail goes up. So y is also positive infinity. How about if we have a given which is a graph? How do we determine the end behavior of the graph? Okay, so here, let's go directly to the sign of the leading coefficient. Do not answer yet here. So the sign of the leading coefficient, again, how do we determine the sign of the leading coefficient? Look at the right tail. This is the left tail, this is the right tail. The right tail goes up. The right tail goes up, so that means the sign of the leading coefficient is positive. Now, how many turns? There is no turn. That means 0. Right? So what is the degree here? If the number of turn is 2, the degree is 3. If the number of turn is 1, the degree is 2. How about if the number of turn is 0, the degree is 1? So this is a linear function. Okay, let's have the behavior of the graph. as x goes to positive infinity, y goes to y. Here, the right tail, it goes up, so it's positive infinity. Next, as x goes to negative infinity or goes to the left, this is going to the left. Left tail is negative. It goes down, so it's negative infinity. There's no sample graph here because the given is already graph. How about number 4? So here, let's go directly to the sign of the leading coefficient. Look at the right tail of the graph. The right tail goes up. Again, the sign of the leading coefficient is positive. Number of turns, 1, 2, 3. How do we determine the turn? The curve, 1, 2, 3. So 3. So what is the degree here? The degree here is 4. Simply add 1. 3 plus 1, that's 4. 1 plus 1, that's 2. 2 plus 1, that is 3. So we have here, do not determine if it is odd or even. The odd or even will determine the left tail, but that is not really necessary because we already know how many the number of turns and it follows. Always start drawing the right tail. Okay, next, let's have the end behavior. As x goes to the right or positive infinity, y goes to, it goes up, the right tail goes up, that's positive infinity. As x goes to the left or negative infinity, y goes to, the left tail goes up, so that means that's positive infinity. This is how you're going to determine the end behavior of the graph. Okay. We have also what we call multiplicity of zeros. This multiplicity of zeros will help you graph easily polynomial function. Now, the function given is f of x equals x plus 3, x minus 2 squared, and x plus 1. This given is in factored form. Factored form. This given is in standard form. Right? Again, this is standard form, this is factored form. Now, how do we determine the multiplicity of zeros? We will just make use of the exponents here. If the exponent is odd, the graph crosses the x-axis, If the exponent is even, it touches the x-axis. Okay. Now, before that, let's look at here, x plus 3. The exponent here is 1, right? X minus 2, the exponent here is 2. X plus 1, the exponent here is 1. There's 1 here. Okay? So let's try to get first the roots. So in finding the roots, if it is factored form, you can easily get the roots if it is in factored form. So x plus 3 equals 0, right? So in finding the roots, we have x plus 3, transpose positive 3 to the other side, that is negative 3. So we have the root is negative 3. Next is x minus 2 equals 0. So x is positive 2. We just transpose negative 2 to the other side. Next, x plus 1 equals 0. Then x equals negative 1. So here, since we're going to graph this one, this is negative 3, 0. Negative 3 is the x. Y is always 0. 2, 0. Negative 1, 0. If we're going to plot that one in a number line, here, this is number line, which is the x-axis. We have here 0, 1, 2, negative 1, negative 2, negative 3. If you're going to plot that one, negative 3, 0, it's here. 2, 0, it's here. Negative 1, 0, it's here. Now, look at the exponent. This is where multiplicity of zeros will enter. Okay, let's start first to the right because we're going to draw it from the right to the left. So 2, here, 2, 0, this is 2, 0, that comes from this 1. So what is the exponent of x minus 2? That's 2. That's even, right? That's even. So, even, it touches the x-axis. Okay? So here, let's go back to here. What is the sign of the leading coefficient here? What is the sign of the leading coefficient? The sign of the leading coefficient is positive. So if it is positive, positive x times positive x times a positive x, that is positive. So positive, right? So the sign of the leading coefficient is positive. So the right tail goes up. So the right tail goes up. So right tail, right? Then going to 2 is, the exponent is 2, even. It touches the x-axis. This is the x-axis. This is the x-axis, so it touches at this point, touch at that point. Going to negative 1, here, it's negative 1 that comes from this one. X plus 1, what is the exponent? It's 1, which is odd. If it's odd exponent, it crosses the x-axis. It crosses the x-axis. So here, there's a turn here, and it will cross the x-axis, right? Going to negative 3, that's negative 3, 0. That comes from this one. What is the exponent? 1. So it crosses again the x-axis. So turn here, then it crosses. This is what the graph looks like. So if you're going to graph that one, how many turns? So what is the degree here? The degree here is 1 plus 2 plus 1, that is 4. How many turns? Turns here is 4 minus 1, that is 3. Let's count. 1, 2, 3 turns. This is what it looks like. How about number 2? Let's try to solve number 2. The multiplicity of zeros. So let's try to determine first the degree. Degree here is positive. We have 2 plus 2 plus 1. We have 5. So turn here is 5 minus 1, that is 4. Expected that there will be 4 turns. What is LC? What is the LC? What is the sign of the LC? Positive, positive, positive. If you're going to multiply all the 4, that will give you a positive leading coefficient. Next, let's have the X-intercepts. X squared equals 0 is 1. Another one is x plus 2 equals 0. And x minus 4 equals 0. So x squared equals 0. If you're going to find x, that is equal to 0. Then x equals transpose positive 2, that's negative 2. X minus 4 equals 0, that is positive 4. So the ordered pairs are 0, 0, negative 2, 0. Again, y is always 0, 4, 0. Now let's plot. So we have here negative 2, negative 1, 0, 1, 2, 3, 4. 3, 4. So let's plot. That's 0, 0, negative 2, 0, 4, 0. Okay. So let's start at the right. 4. 4. What is the exponent of 4? It's 1. It touches or crosses. 1 is odd, so it crosses here. Now, the LC is positive, so the right tail goes up. Goes up. It cross, going to this one, so turn 0, 0. What is the exponent of 0? 2. That is even. It touches the x-axis. So here is 0, 0. So touch. It will not cross because the exponent is 2. So touch the x-axis. Then at here negative 2. Negative 2. What is the exponent of negative 2? That is still 2. It is even. It will touch the x-axis. So turn. Then turn. So let's check. This is what the graph looks like, where there will be 4 terms. 1, 2, 3, 4. Okay, so you already know how to get multiplicity of zeros. Okay, I just want to make clarification of the Descartes rule of sine. In Descartes rule of sine, again, in Descartes rule of sine, Descartes rule of sines, you will just subtract it will just about the change of the signs. So for example here, it is already arranged in descending order of powers. So negative 3, from negative, it becomes negative, so it did not change. Then becomes positive, so 1. So positive is 1. Positive is 1. How many are negative? 3 minus 2. Negative, we have 2. Here we have, take note of this, 1, 2, 4, 6, 8, and so on. 1, 3, 5, 7, 9, and so on. Since 2, 1, there's no number lesser than 1 anymore. So 2. If this is 2, therefore, what is the number less than 2? We have 0 or 0. So if you're going to solve the roots here using Descartes' rule of sines, there is one positive root. The negative roots, we have 2 or 0. It could be 2 or it could be nothing. Example, this one. How many are positive roots? So let's count the chains. Positive, positive, no change, positive. So the positive is 0. The negative is 2. 2 or less than to this. 2 or 0. How about this one? How do we determine the positive and negative roots using the Descartes rule of sine? So in positive, so let's count the number of sign. Positive becomes negative, 1 change, becomes negative, positive 2, 3, so 3, 5 minus 3, that is 2. So following the rule, what is this? Is 3. What is number less than 3 here? That is 3 or 1, 2 or 0. So there could be 3 or 1 positive roots, 2 or 0 positive roots. So this time I will teach you how to graph now polynomials. So we have steps here to follow in order to graph polynomials. So we have here example number 1. f of x equals x to the power 4 minus 2x cubed minus 3x squared. This is in standard form. So, step 1, use the leading term test to determine the end behavior of the graph. You already know how to get the end behavior of the graph. So here, let's have first, what is the degree here? The degree is 4, right? It's 4. What is LC? The sign of the LC, it's positive 4. So it's positive. How about the turns? How many number of turns? So 4 minus 1, that is 3. Okay? What does the graph looks like? So since LC is positive, the right tail of the graph goes up. How many turns? 3. 1, 2, 3. Okay? So the graph must be rises right and rises left. Now step number 2, determine the x and y intercepts. In determining the x intercepts, you must get first the roots or the values of x. Okay, how do we do that? You can also use synthetic division to get the values of x, to get the roots. If the remainder is 0, therefore that's one of the roots. Or you can also have factoring. Okay, suppose this one. So the given is, let's solve first the x-intercepts. In solving the x-intercepts, we're going to get the roots. So in the given, f of x equals to the power 4, x to the power 4 minus 2x cubed minus 3x squared. So we have here, first one, we have common terms, x to the power 4 minus 2x cubed minus 3x squared. They have common, which is x squared. So x squared divided by x to the power 4 divided by x squared, that is x squared, minus 2x cubed divided by x squared, that is 2x. Negative 3x squared divided by x squared, that is negative 3. Okay, so we have here f of x equals x squared. Factors, let's do factoring here. So x squared minus 2x minus 3, this is already a quadratic function. Factors of x squared, we have x and x. Factors of negative 3, when you add, it's negative 2. So 3 times 1 is 3. What should be the sign of these two factors? When you add, it's negative 2. So this should be negative and this should be positive. Because negative 1 times negative 3 is negative 3. Negative 3 plus 1, that is negative 2. Okay, here we have now the x-intercepts, x squared. Let's get this one first. So x squared equals 0. X plus 1 equals 0, equate to 0. X equals negative. X minus 3 equals 0. So x here is 0. X here is negative 1. X is positive 3. So the x-intercepts are, it must be ordered pair. So 0, 0. Y is always 0. Negative 1, 0. 3, 0. How do we get this one? It's up to you. If you're going to try this one using synthetic division, the remainder should be equal to 0. Okay? So these are now the x-intercepts. 0, 0, negative 1, 0, 3, 0. Sir, the exponent is 4. Why there are only 3 zeros? Let's try to check using Descartes' rule of sign. Descartes' rule of sign, we have positive, that becomes negative 1. That becomes negative 1. So there could be there could be the positive root, we have only 1. So 4 minus 3, 4 minus 1, that is the negative root, which is 3 or 1. So 1 positive, which is 3. Negative, we have, it's not 3, but it's 1. 4 is expected root number of roots because the highest exponent is 4. So we have 2 zeros here because this exponent is 2. So 1, 2, 3, 4. Okay, let's now solve the Y-intercept. So the Y-intercept, in solving, let x equals 0 always. So substitute this one. F of x equals x to the power 4 minus 2x cubed minus 3x squared. F of x is 0 equals 0 to the power 4 minus 2 times 0 cubed minus 3 times 0 squared. 0 squared, 0 to the power 4 is 0 minus 0 minus 0, so that is 0. So f of 0 is equal to 0, so the y-intercept is 0, which is x, y, which is 0. So at 0, 0. Now intervals. How do we get intervals? Or test value of x. So we have test value of x here. How do we get the intervals? So let's try to plot that point. So let's try to plot the x-intercepts. So we have 0, 0, 0, 1, 2, 3, negative 1. We're going to plot the x-intercepts. That's 0, 0, negative 1, 0, 3, 0. So here, let's get intervals, or means let's find another numbers which is located to the left of this one. There are 3 points already here, so we will find another points or numbers. We have here to the left of this one, in between of these 2 points, in between of these points, and to the right of this one. What are the numbers to the left of negative 1? You can choose any numbers as long as it is located to the left of negative 1. So let's have negative 2, right? To the left of negative 1 is negative 2. Now let's find a number here. In between negative 1, 0. Between negative 1 and 0. So we have negative 1 half. Negative 1 half is located in between 0 and negative 1. Next, in between 0 and 3. Between 0 and 3. What are the numbers in between 0 and 3? Still at only 1. It could be 1, it could be 2, it could be 0.5, it could be 1.5, 2.5. Any numbers as long as it's in between the 2 numbers 0 and 3. So I will pick 1. Right? Next is to the right of 3. Right of 3. So which is to the right of 3 we have, I will choose 4. So these are the intervals, negative 2, negative 1 half, 1, and 4. The test value of x. Okay, this multiplicity of zeros will help you whether the graph touches or crosses the x-axis. So let's make use of this. So in here, it's negative 3, a positive 3. What is the exponent of positive 3? It's 1, 1, 2. So exponent of x minus 3, the exponent is 1. The graph rises to the right, so it's like this. So it crosses the x-axis. It crosses the x-axis because the exponent is 1. Now let's go to 0, 0. What is the exponent of 0, 0? Here, 0, it's squared. 2 is even, so it touches the x-axis. It touches the x-axis. Next, go to negative 1. Negative 1, the exponent is 1, so it crosses So it's the x-axis. So this should be the graph looks like. Now let's proceed to step number 4. Step number 4. Let's have the test value of x. So we have the test value that comes from the step 3. Step 3, test value of x, we have -2. It's the left of -1. Next is -1/2. Next is 1. And next is 4. Now, the given function is here. So, f of x equals x to the power 4 minus 2x cubed minus 3x squared. X will be substituted by -2. So, f of -2 equals -2 to the power 4 minus 2 times -2 to the power 3 minus 3 times -2 to the power 2. That is equal to, so if we're going to solve that one, so f of -2 is equal to 20. So this is 20. So the test point is -2 and 20. So what is the sign of f of x? What is the sign here? 20. That is positive. If it is positive, the location of the point is above x-axis. Okay? The location of this one is above x-axis. Now let's go to f of -1/2. F of -1/2 equals -1/2 to the power 4 minus 2 times -1/2 cubed minus 3 times -1/2 cubed. If we are going to solve that one using calculator, that will give you -7/16 or -0.4375. So the test point here is -1/2 and -7/16, which the sign is negative, and if it is negative, it is located below x-axis, below the x-axis. What is f of 1? F of 1, substitute x by 1 here. That is equal to -4. So -4. So this is 1, -4. So here, the sign of y here is negative. That is below the x-axis. Okay, so next is f of 4. F of 4, x becomes 4 to the power 4 minus 2 times 4 to the power 3 minus 3 times 4 to the power 2. That is equal to, when you simplify that one, that is equal to 116. So 4 and 116. So the sign is positive. So it is located above the x-axis. So this time you're going to plot, or we're going to graph the polynomial. We're going to graph the polynomial. So in graphing the polynomial, you have this one. You have the x-axis and the y-axis. What we're going to plot here are the x-intercepts, y-intercept. There's only y-intercept. The test points. What are the x-intercepts? X-intercepts, so we have 0, 0, -1, 0, 3, 0 in step 2. And the y-intercept, which is 0, 0. Y-intercept, we have 0, 0. Next is the test points. Okay, so let's plot. 0, 0 is here. 0, 0. Next is negative 1, 0. It's here. Next is 3, 0. It's here. Next, the y-intercept is 0, 0. We have already 0, 0. Next is negative 2, 20. Negative 2 of the x-axis, positive 20 of the y-axis. Negative 2, positive 20, so we have here. Next is negative 1/2 and negative 7/16. Negative 1/2 is here. Negative 0.4, it's over here. It's almost here. Okay, it's here. 1, negative 4. This one, not this one. Next is 116. 116. 4, 116. It's 4. 116. It's here. 4, 116. It's almost here. So the graph should be like this: rises right, rises left. Crosses, touches, crosses. So we have here crosses that goes, it rises right, it attaches 0, it crosses negative 1. How many terms? 1, 2, 3 terms. This is now the graph of your polynomial. This is f of x equals x to the power 4 minus 2x cubed minus 3x squared. We have here example number 2. Degree here is 2 plus 2, that is 4. LC is negative. Turn, we have 4 minus 1, that is 3. So the graph, since this is negative, the right tail goes down 3 turns. 1, 2, 3. So at the end of the step 5, we have a graph looks like this. So determine the X X-intercepts and Y-intercept. So here you can easily get the X-intercepts because it is already in factored form. So x minus 1 equals 0 and x plus 1 equals 0. So x is positive 1 and x is negative 1. So positive 1 and 0 and negative 1 and 0 are the x-intercepts. How about the y-intercept? Y-intercept, we have let x equals 0. F of 0 equals negative times x becomes 0 minus 1 squared, 0 plus 1 squared, that is negative. 0 minus 1, that's negative 1 squared. 0 plus 1, that's 1 squared. Negative 1 times negative 1, positive 1. 1 times 1, 1. Negative 1 times 1 times 1, that is negative 1. So the y-intercept is 0, which is x. Y is negative 1. This is the y-intercept. The intervals. So we have 1, 0 and negative 1, 0. 0, 1, 1, 0, negative 1, 0. Numbers here, numbers in between the two, and numbers to the right. Left of negative 1, we have numbers left to negative 1, that's negative 2. Between negative 1 and 1. Negative 1 and 1, that's 0. Right of 1, I will choose 2. So we have only here. Multiplicity of 0, so we have here x minus, here, let's start, x plus 1. X plus 1, positive 1, 1 and 0, that's here. that is x minus 1, the exponent is 2, so it touches the x-axis, and the leading coefficient is negative, so it goes down. So here 1, then going to, it also touches the x-axis, so let's look like this one. Okay, so let's go to test step 4. So what are the test value here? We have left of negative 1, that's negative 2, 0, and 2. So we have here, the given is f of x equals negative x minus 1 squared times x plus 1 squared. So we have substitute negative x to negative 2. So f of negative 2, that is negative 9. So here is negative 2, negative 9. The sign is negative. It is located below the x-axis, Next, f of 0, when you substitute x to 0, that is equal to negative 1. So here is 0, negative 1, negative below x-axis. Next to f of 2 equals negative 2 minus 1 squared times 2 plus 1 squared, that is equal to negative 9. So that is 2, negative 9, negative, so it's still below x-axis. Okay, so we have here step 5, negative 1, 0, and 1, 0. Y-intercept, we have 0, negative 1. And the test points here. Okay, so in plotting, so let's plot now the points. Negative 1, 0, negative 1, 0, 1, 0, 0, negative 1, 0, negative 1. It's here. Now there is the test points. Negative 2, negative 9, negative 2, negative 9. It's here. Next is we have 0, negative 1. We're done. Next to positive negative 9, positive 2, negative 9 here. It's here. Okay, so the graph LC is negative, so it's going here. So therefore LC the right tail goes down. So touches because the exponent is even. Then turn, then touches negative 1 going to here. So this is now the graph of f of x equals negative times x minus 1 squared times x plus 1 squared.